Good. Thank you.
Well, yeah, I can see the little recording guy. So, happy Wednesday, everyone. As Bill said, my name is Zack Gardner, coming to you live from Kansas City, where in my neighborhood, apparently, July 11th is still a good day to celebrate July 4th. So I think everyone has calmed down since then, so you shouldn't hear any fireworks in the background. But if they do, you know what? It's Kansas City. We kind of do our own thing. Today's presentation is going to be my experience using Azure SignalR as well as Cosmos DB. I'll kind of go first through the background for the business use case, some of the ideas that we went through that we then discarded, and why we landed on Azure SignalR as well as Cosmos. I'll talk a little bit about the pros and cons, because honestly, if you attend a presentation and they don't tell you the downsides or the gotchas with what they're doing, they're trying to sell you something. And this is totally egalitarian advice. You know, I am here of my own free will. If Microsoft wants to send me some Bitcoin or, I don't know, some Bill Gates coin, like whatever Microsoft's crypto is, like feel free. I mean, I'll put my address up, but this is totally because this is a topic that I care about. It's something that I want people to learn about. And I hope that you all, if you choose to go down this route, and if you have similar use cases that you might see yourself using these things, that you don't have to go through the same pain that I did to get to where I landed. So that's kind of the summary of where we're going tonight. So to start with, like Bill said, Zack Gardner, Zack the Snack is what my UX friends typically call me because I always bring snacks into the office. I've actually, I think, been promoted since I sent that bio. I'm now the chief architect, which means I'm kind of like the fun uncle, so to speak. You know, everyone comes to me, I get to learn about a little bit of this, a little bit of that, get some experience in a lot of different areas. I primarily spend my days on a health system in New York City. You know, sort of behind the scenes look at it. Most of our patients actually have appointments at Dunkin' Donuts instead of Starbucks. So I think the Boston spirit, even though it's in New York City, I think the Boston spirit really is alive and strong, at least for a lot of the patients that we serve. I'm an architect primarily on a post-acute EMR, though I do work as well in some of our energy clients, some of our fintech clients, mostly living in Azure, hence speaking to you all tonight, though I am getting more into Google Cloud. Nothing against Microsoft by any means, just trying to hedge my bets and trying to figure out, you know, how different clouds do different things. So that's a little bit about me. Now, let's talk problems. Let's talk applications. Let's talk the things that we're really here to talk about tonight. And as you can tell, based on my screen, I might have rewatched season 1 of White Lotus while I was coming up with this presentation. So shout out as well. So as an architect, there's a lot of different ways that you can approach solving problems. How I approach it, maybe it's the right way, maybe it's the wrong way. I don't know, it's my way. I really like to understand what my users are doing. What is the business problem that I'm setting out to solve? And then figure out the right technical solution. I think one of the downfalls, honestly, a little bit of a sidebar of blockchain, is the fact that it was more of a solution in search of a problem. And I try not to do that, not dogging on anyone that has done blockchain. So let's talk about the business use case that I was presented with. I work with a lot of different groups within the health system, but the clinical call center has always had a very special place in my heart. If you ever meet a clinical call center agent, give them a hug. They have a very, very difficult job. They are under an incredible amount of stress. They talk to people on the phone. They need to triage things very quickly. Their life is difficult, much more difficult than the life of an average programmer. So if you see one or you see a nurse, give them a hug. But what happens in a clinical call center is that a patient or maybe a family member of the patient will call in. And depending upon which call center it is, there's different technologies that they use to answer the phone. I mean, you could literally use one of those big old landlines But honestly, these days, most clinical call centers don't do that. What they use are called soft phones. The one that I was working with actually uses a VIA agent for desktop. That's what the AAFD stands for. So the patient calls in, it gets routed to someone's laptop that's running the software, and then they can connect to it via their headset. And it's a desktop application. So just keep that in mind. The clinical call center agent will pick up the phone, and within the first 10 seconds, they have a lot of things that they need to figure out. Probably the most important which is, do I need to route this person to emergency services, aka an ambulance, immediately, or can I talk things through with them? And then if they don't need an ambulance right now, are they having suicidal ideations? Because we also deal with a behavioral health population. And then if they don't do that, there's like this big decision tree that you can think of it as for how they do clinical decision support, how they figure out what is the next step that I need to take once I get this call in. Then, as they are talking with the patient, they need to look up their records, see if they have any known allergies, see what medications they're taking, figure out who their primary care provider is. Like it's a lot of stuff that we have given these clinical call center agents to do. All of the documentation, all of the looking up, everything that they need to do for their day job when they're receiving these calls and document, they need to do in an application that we've built for them, which is a React single page application running in their browser. And the problem for us from a technical standpoint was always the disconnect between the two. I mean, we have this soft phone running in a desktop application, and we have our web application running in the browser. Now, back in the day, I'm kind of dating myself, but back in the day, we could have done something like applets, or we could have done something like Flash. Thank you, Steve Jobs, wherever you are, for killing Flash. That's no longer an option. So how do we, from a technical standpoint, communicate between our browser, our web application, and their desktop application? That's sort of the biggest technical hurdle that we had to figure out how we would overcome. The other technical hurdle was so a patient calls in. If they're calling in from a cell phone number, there's a high likelihood that the phone number that is the inbound would match something already in one of our systems. If it's a family member calling about the patient, we can't really pre-fill a lot of information, right? Because maybe the phone number they're calling in is the daughter, and they're calling in because maybe their mom fell, and their mom's maybe 60, 70, 80. So we don't want to pull in the daughter's information. We want to pull in the mom's information. So then you have to go from the phone number up to the person, up to the relationships, and then let the user pick which is the caller and who is the patient, because they might not always be the same. There's a lot of really, really useful information that we have from this API where we can get a phone or give it a phone number and then get back information. Problem is that API that we were calling is very unpredictable. Sometimes, depending upon the phone number they call in with, if it's a cell phone number, the responses are going to be really snappy. If it's a staff member at a skilled nursing facility, a SNF is actually what we call it in the industry. A nursing home is probably what the laity would call it. There are a lot of patients more than likely attached to that phone number, and it can take a long time for that API call to return. Sometimes, if it's a Saturday and there's nothing else going on, no matter what number you put in, it's really fast. Monday morning is always the worst for that API because people are coming back into the office, they're filing documentation, there's a lot of traffic hammering the server that's taking that request. So response times, I mean, there is no SLA. It's just sometimes it takes 5 seconds, sometimes it takes 50, and good luck. So we have an API that we could use to provide the information to the user, but it's really inconsistent. So those are our two technical, not constraints, but considerations that we need to keep in mind. From a business standpoint, the two biggest complaints they had, one, depending upon who the caller is, maybe if they are an employee of a particular organization, there's one set of questions that they need to go down. If they are having suicide ideations, then they need to go down a different set. If they're having shortness of breath, they need to go down yet another set. It's really hard, especially for people in the medical field who know how to communicate with patients, that's what they've been trained to do, to understand all the complexities and to make sure that they're doing the right check boxes and they're putting the right drop-down values in all these specific places to make sure that that documentation is consistent, which prevents them from being able to onboard people quickly. They're sort of a symbiotic considerations. Because if you can't train someone on all the different scenarios that they're going to need to know, then you're going to get really inconsistent documentation. You're going to have employee burnout. You're going to have people that are very unsatisfied and disgruntled. I mean, it's a tough job to begin with. And we have somehow, some way, made it more difficult for these people by building this application without being able to connect those two pieces. So how? I'm clearly presenting something because we did something. What did we do? How did we do it? In a second. The first piece is we need some way to tie together the desktop application with our web application. Depending upon what soft phone software they're using, they're usually, I'm hedging my bets because I don't know all the pieces that could possibly be out there, but usually there is a way to configure it on the agent's machine so that when they get an inbound call to them or when they end a call, that desktop application can actually issue an API request. So that was the first piece of the puzzle. In Avaya Agent for Desktop parlance, it's called a screen pop, which I don't know about you all, but a screen pop being an API call is not what immediately comes to mind on that Rorschach test, but I don't know. Maybe it made sense to whoever wrote it. So not digging on them at all. Just kind of interesting word choice. Inbound call comes in. We can configure it on the agent's machine so that it makes an API call or an HTTP call out to our API. And it can pass us things like who the caller is, what the phone number specifically that they are calling in with is. We can configure it to say who the agent is that picked up, what phone number the patient called into, because a single call center might have multiple phone numbers that they give out depending upon different what they call campaigns. There's a lot of different reasons for that, especially if you're getting into scenarios where you can text the patient. When they text stop, it's really for that phone number. It's not for the company as a whole per FCC regulations. I hope I got that right. Since it's being recorded, that's just what I recollect from that call. So there's a lot of reasons why you might give out different phone numbers, and maybe which workflow you want the user to go down depends on what phone number the patient called into, not even just what phone number or what device or whatever the patient is calling in with. So we can get this desktop application to send an HTTP request out to our API. How does the browser that's just, it happens to be sitting on the same machine, how does it know that information? How do you relay that information back to the browser? There's a couple different ways that we tried and spectacularly failed to solve this problem. How I've done it in the past, I mean, this was circa 2011, I think was when I tried something like this. You can use JSON-P, which essentially means you create a long-running JSON, like AJAX request to a server. And instead of waiting or instead of thinking about it as in, it's going to be a 200 OK, and then it gets the data, you're essentially keeping that pipe open. And on the server, instead of doing like a complete request, you push stuff, you push data into the body of the response, and then you flush the response. It's not supported on all server technologies. I mean, I was doing it in PHP back in the day, and it just so happened to be supported there. It's not ideal either, because most browsers, you get 6 TCP connections per tab instance. And if you keep one of the, what's really per host, and you keep that open the whole time, you're really limiting the amount of connectivity that can happen on all those other TCP sockets. So especially if you're getting into scenarios where the pipeline isn't fully utilized, if it's just sporadically utilized, you're using a lot of resources and you're keeping that TCP connection open for not a lot of data. So there are definitely, it is a way to do it. It's one that I wouldn't really recommend. Polling is another option. Maybe you have something inside of a set timeout or a set interval on your web application that periodically hits an API that says, all right, I am this agent. Do I have any incoming phone calls since the last time I checked? And when that screen pop hits the API, maybe it appends a record into a database. And then when the polling API gets hit, maybe it checks that same database for the particular agent. That's one way to do it. There's some obvious problems with that. How do you know how frequently you should poll? Should you do it every 15 seconds? Should you do it every 30 seconds? What happens if you do it every minute, and then right after the response comes back, you get a patient call? You're going to have to wait a full minute before it tries to automatically load and hit that API in the background. You could possibly introduce a button for the user that they can click on that then triggers the API call to then see if the record has been appended into the database. Users are not a fan of this. And the best way I can think of to explain it is, imagine you had their job. Imagine you were getting a call and you then had to click a button. You probably wouldn't be too happy about that. Maybe you're a person that loves to click buttons. Maybe you're insane a little bit. I don't know. You might be. I wouldn't want to do it. And I certainly don't want my users to do it either. So we went through a lot of different ideas. The one that we landed on was Azure SignalR service, which, if you've never used it before, imagine there's a bidirectional pipeline between maybe a peer-to-peer pipeline is a good way to think about it, between the user's browser and your API. Don't think of it as a client and a server. You know, so much of what we do in our day-to-day life has been always this client-server mentality. There's a very well-defined client, usually written in React, or if you're crazy, Angular, and it's always making API requests when the user clicks a button or the user logs in, or there's some triggering event on the browser that causes us to act as a client, and we need to pull down data from the server. I mean, it's been this way since I have been developing since I was like 14 years old. WebSockets and SignalR put the idea on its head, and how they conceive of it is there are two clients that need to exchange information with each other. Maybe client is even the right word. Maybe it's more a peer. There's this browser and it needs data. There's the server and it needs data. And they can communicate back and forth at any given time. They can send whatever they want on this pipeline. They could send JSON. They could send XML. If you want to be really mean, you could send SOAP. I mean, there's no prescription on what goes between on this pipeline. The only thing that really is there is just the fact that you can receive any given message at any given time. And it's not lossless. That's an important point to make. If this was a system that, like, a patient's life is truly in danger, and it's not just, you know, we need to record a phone call and the interactions. I mean, we're talking like, if this is in an emergency room and this thing needs to work, not just 99.999% of the time. I mean, it needs to work 100% of the time. I'd be skeptical about using WebSockets, because if the server acting as a client or a node or a peer sends a message and the web browser isn't there yet, it's not going to get those. So then you need to build in like retry patterns, and it's complicated, especially because even if we're on an internal network, there are things that you need to consider. So SignalR is a wrapper on top of WebSockets. All the browsers that we were using that we had to support, thankfully, did support WebSockets. But if you misconfigure your Azure web app, which I personally know someone that did, me, WebSockets aren't enabled by default. So then SignalR actually allows you to go and do sort of a graceful fallback without all the code around it really having to care. So it was super nice. It allowed us to quickly spin up a SignalR hub that both our web UI and our server could connect to. And the crazy thing about it, this is like open source. I mean, I kid you all not, like when I started developing, never in a million years would I thought Microsoft would be a pioneer and produce this kind of quality tooling and make it open source. Now, granted, full disclosure, the Azure SignalR service, I mean, they're not running a soup kitchen. This thing does cost money to be able to use. Comparatively, though, it is much cheaper than a lot of the alternatives. I was actually giving this near same talk in Vancouver a couple months ago at a Linux Foundation open source conference. So, I mean, it's just crazy. Kudos to anyone that works at Microsoft. There's a lot of really cool open source work that they're doing. And it's getting used, too. You can see from this SignalR NuGet download chart that the amount of downloads that it takes, I think I took this in, it was earlier this year. And I kind of looked at, how many people download it per, week. You can see some dips, which is usually because of Christmas or Easter or Thanksgiving. Those are always slow times in the software development community, but it's been steadily growing. And it's gotten, I think, over 60 million downloads since it came out. So it's fairly widely used. Now, full disclosure, WebSockets in general, there's a lot of different tools that are out there that you could use instead of SignalR. One of the big reasons, if not the big reason, why we chose it is because Azure has it as a managed service. And in as much as I can, as an architect, I have found that managed services allow me to do things like take my wife out on a date night and not have to worry about something going down, about having to take my laptop and SSH in and reboot something. It allows me to not have to be an expert on all the different configuration options that you need to do upon installation. It allows me to not have to worry about if I have it on a cluster and one of the nodes goes down, how do I rejoin it? None of that stuff you got to worry about. Whereas if you had your own sort of self-managed instance of SignalR, you'd have to do things like create a backplane, and it's complicated to actually get one of these things set up. So, shout out to anyone on the Azure SignalR team. Like, my wife is very grateful because we were able to go out on date nights and not have to worry about things like this. So to recap, kind of where we're at. Patient calls in, soft phone desktop application does a screen pop out to an API. It passes in the inbound phone number, the phone number that the patient called, who the agent is. That API publishes a message on SignalR. The message that it publishes, and there's two different flavors of messages. You can either direct a message at a specific user, or you can direct it to a group. Kind of like a topic is a good way to think about it. If you broadcast a message to a user, only that user is going to get it and no one else. So that sort of inherently takes care of any permissioning issues, any security issues. It is going to, I gotta say this very correctly, that message is going to any browser tab that the user has signed into. And this is the cool part, right? Because our users, we found out, were running our application in multiple tabs. So one message would actually get fanned out to all those different tabs that they were using, because all the different tabs were connected to that same central SignalR hub. Now, I say single. Behind the scenes, it is actually horizontally scaled, so it's not a single point of failure. Additionally, it is a progressively enhanced functionality of the application. That's honestly the mentality I would take when using SignalR or WebSockets in general. Because it is something that could fail, you should account for that by not putting it in the critical path of your application. Messages might be dropped depending upon connectivity going in and out. It does have the ability to, and kudos to the team, to be able to reconnect automatically. But if there are any messages that get published in that interim, that is something as an architect that you are going to have to take into account. Do you need to do replays? Do you need to do a catching up phase? It depends on the application. There's no one answer that I can give. We thankfully didn't have to account for that. We're on a very stable network. People are calling from inside a VPN, the API calls, so we were good. But if you're using this with the public internet at large, that is something you're going to have to take into account. So the message goes from the API up to a SignalR hub saying, I want to send a message to this agent, and then the message then gets fanned out to all the different browser tabs that the agent has logged into. It's possible that the agent could actually be on multiple different laptops. All of them would get that message simultaneously. Isn't that crazy? I could have never thought of this when I was 14 and just programming. So the React browser sitting on those tabs receives the message. It then is able to say, oh, this is the phone number that called in. This is the user. This is all that stuff. But we still have an interesting problem, because remember that demographic API that I talked about earlier? It still requires us to be able to hit it with the phone number for it to return information. And the SLA behind that API, it's variable. It totally depends. If Saturn is in retrograde and a butterfly flaps its wings in Tahiti, it's going to take 45 seconds on that specific moment. And other times it'll take 4 seconds. It just totally depends. So instead of having the user click a button and then show a loading icon and then have to worry about configuring the default jQuery Ajax timeout, we weren't using jQuery, but instead of having to do all that, what you can do is this. The call comes in, goes to the soft phone makes an API call. When it sends the message to the SignalR hub at the same time, it can then make an API request out to that demographics API. It gets the response back, and then it publishes another message on SignalR with those demographics. The cool part about that is that it doesn't couple those two messages together. You might have some scenarios where the browser gets the message about the incoming phone number, and then it gets the demographics message. Sometimes, depending upon if the API is fast enough and depending upon the order of the messages, maybe it gets the demographics response before it gets the phone number. These are all things that you have to account for because it's fundamentally different than Ajax calls. The browser is no longer the one that is able to very clearly control the order of the request that it's sending and the order that it's getting the responses back. I mean, granted, before, it couldn't always account for when the responses would come back, but it at least could tell when it wanted to issue a request. When you're dealing with WebSockets, and this is not anything about Azure SignalR service, this is just how WebSockets work. Sometimes you could get messages in any order, and I've seen it happen before. And it's not the fault of the API, it's nobody's fault. It's something that you have to account for when you're designing your JavaScript and be able to handle at any place in the application the fact that you are getting one of these messages. Testing it becomes extremely exciting. It's fun. It's fun. It was a good little experience. So What did I learn out of this? For starters, I learned that you want to take any integrations that you do and externalize them. What does that mean? Imagine you have an Azure web app. It has a finite number of threads because, we deal in the real world, except for the qubit world, the quantum world. This is the real world. We have a finite number of threads that we have to consider. That API running in that Azure web app is primarily there, I would say almost entirely there, to be able to serve API requests from the user. If you tie up the threads waiting for API calls to come back, you're going to be setting yourself up for failure. Now, there are some strategies that you can use, like async, await. Those will free up the thread so they're not just sitting there doing needless work, but you still are constrained by the fact that your application and its performance is largely dependent upon all the third-party services that you're hitting. And I kid you not, about a month, maybe a month and a half ago, we had a production issue with, an organization that we were helping out, and their system went down at 2 a.m, and it coincided with the weather API that they were calling going down at almost exactly the same time. And it was because their application, when it made API requests, like got an API request, said that, hey, give me the weather, it went directly out to this third-party API that they didn't control, that they couldn't enforce SLAs on. It's a public API. There's nothing you can do about it. You are just another person out there in the wild. If you do that, you're setting yourself up for failure. And we found this out rather harshly because that demographics API, it would cause the performance of our APIs for the 50th percentile to shoot way up when their stuff shot way up. So what you should do instead is imagine the scenario I was talking about earlier. We get the API call. We pass that message off through Event Hub or Service Bus or any of the other eventing mechanisms you can use to what's called an integration engine. And this is probably my favorite architectural pattern that I've seen in healthcare, is the fact that we externalize all of our integrations with third-party systems to an independently deployable microservice, is a good way to think about it, to where if the contract on the other end changes, I don't need to necessarily deploy my application as a hotfix, because then you have to take into account things like downtime notices, what happens with people when they're midway through a long session and then you mess them up by redeploying. You have to get cab tickets. It's even worse on, on the DoD side with like ATOs. Like, it's crazy to be able to deploy hotfixes to production. What you can do instead is, if your API sends an event to an integration engine, that integration engine can be a completely different web app. You could even do a web job inside of a web app. That's actually what I recommend most of the time. That can be deployed completely independently of your application. And if a contract changes or the API that you're calling goes down, maybe you have a little feature flag that you just flip off and say, you know what? This was a third-party call. The functionality is not available. All you're going to get is this phone number that the user is calling in with, the patient, and then you have to go do the lookup yourself. Now, granted, the users, the clinical call center agents, probably aren't going to like it, but we always have to make trade-offs in software. The second thing that we found that was not necessarily a con, it's more of an implication. When you're dealing with a traditional web application, you have your React front end, you have your .NET back end. It's easy to run both of those things together on the same laptop, as long as your laptop has like 8 or 16 gigs of RAM and a solid state, you're probably going to be okay. Not a big deal. When you introduce WebSockets into it, it gets to be a little bit more resource intensive. And if your organization is not super progressive in terms of giving developers the hegemony to dictate the specs for their laptops, you might very easily run into situations where you just don't have enough resources on your system to get all of these pieces running locally. Now, granted, you could probably connect your API and your UI to a dev Azure SignalR instance. That's probably fine. You'll just, if you get any messages on the dev environment, it's going to fan messages out to all those, which might be okay. It's just something that we ran into that makes it a little bit more complex. And having all these things running simultaneously, my laptop kind of sounded like one of those SpaceX Falcon rockets. I mean, it was going to like shoot off into the stratosphere, the magnetosphere. So, you know, fair word of warning. If your music is loud enough, you probably won't even notice. And the third, I wouldn't say it's even a con. You just have to consider at the very beginning of using this where the messages are going to be going. Are the messages going to be going to a user or a group? SignalR, like I said, is not the only option. There are a lot of other technologies that have different philosophies behind where messages go and how to structure them. But in the end, we were extremely happy with it. If you were to, and I actually have an ebook that I wrote about my experience doing this. If you were to set up an Azure SignalR service, like from beginning to end, it would take you maybe 10 minutes, and 8 of those minutes are just sitting there on the Azure portal, like waiting for the instance to be created. And then the other 2 minutes are like actually wiring it into your application. I mean, it's honestly not that hard. The barrier to entry is low. What you run into when you use WebSockets is that you can get this near real-time lossy, I mean, I would say lossy, it's probably like 8 or 9 nines level of communication, but it's difficult. It's definitely a mind shift compared to traditional AJAX calls. And as long as you're using it appropriately, as long as you're being an adult about it, and you think through the implications, and you structure your UI so that you can receive any message at any given time, then you're probably going to be okay. But I will just honestly say, it probably took us a good 2 months of using it before we truly understood how we wanted to structure it in our code. If you're interested in learning more about the experiences that we faced, what are some of the different gotchas that we have, you can scan the QR code, and that'll send your email address, and so I'll be able to get in contact with you afterwards. And if this is something that you are seriously considering that you need a use case for, I would strongly recommend Azure SignalR service. We've been happy with it. Downtime has not been an issue. And once we sort of got over our own development hurdles of just understanding how to use this tool, it became a really powerful tool in our arsenal that we are recommending not just to this client, but any client that comes to us and needs this sort of real-time, async, peer-to-peer style communication, especially if they're on Azure. It's an absolute no-brainer. And it is something that I would strongly, as long as you keep all the things that I said in mind, as long as you keep those at the forefront, I think you'll be okay. So that's it. That's Azure SignalR service in a nutshell. Just with great WebSocket power comes great responsibility. So questions. What do you all want to know? What did I say that was sounded crazy or that you need more clarification on? Hit me with it. I want to know.
Jason, is it technically possible for folks to unmute themselves if they have a question?
Yeah.
Okay, just checking. So feel free. Anybody has a question for Zach? I do have one question for you, Zach, which is, can you say a little bit about the debugging experience? Like how, as you're getting to know it over those couple of months, what were some of the tips and tricks for figuring out what was really going on?
Funny you should ask. The SDKs that come along with using Azure SignalR, there's a JavaScript library, and then there's a React wrapper on top of it, and then there's a .NET NuGet package. They are very 1960s, sort of free spirit about what you can put on there. Just like when you are constructing controllers and methods for API calls, I mean, you can call them like whatever you want. You can pass whatever you want. But most groups of any size, when it comes to API calls, will enforce some patterns, some structure, some common code that everyone uses to put API calls together. And then when you're doing code reviews, make sure that everything looks fine. So the first thing that we really had to do was put not a wrapper layer, but maybe an interface layer between our JavaScript and those libraries so that we could enforce things like always including a GUID when you're publishing a message for a correlation ID. So when you put a message on SignalR, we log that with the correlation ID. And then when you receive a message before it gets passed off to your handler, we record and log that correlation ID as well. So that actually allowed us to see what messages were going where. And it also helped sort of us figure out what was going on because it's a distributed system, essentially. So I would highly recommend not putting an abstraction on top of an abstraction for abstraction's sake. I would recommend having maybe a wrapper layer where it makes it very easy and convenient, and you can hide some of the implementation details of connecting to SignalR on top of that. Outside of that, I would say most of the issues that we had were copy pastas, where we did the casing wrong on one side or another. There's no, as far as I know, analogous technology for SignalR like there is on the API side for Swagger. I mean, Swagger is such an amazing tool. It's the contract gets live updated between the UI and the API, and you can see exactly what the request and the response structure is like. There is no tool, as far as I know, and I mean, anyone can come off and correct me if I'm wrong, please do, that allows you to do the same thing for SignalR. So you have to be very diligent in where you put your documentation. And if the contract changes on either side, you have to manually update it. The best way to get your feet wet with SignalR and WebSockets in general is to sort of build your own administrative Swagger page where you say, this is the message, this is the payload that you will get it with this message, and then allow the browser to go back and forth between the service. I mean, that's what we ended up doing, and it has helped, and it's a good exercise, sort of like, when a child learns how to walk, that's kind of the steps that they go through before they can run. It really gets you in the mode of thinking through like how SignalR conceptualizes of these messages. And then, added bonus, you get a live working sort of Swagger-ish interface. Once we got through those steps, I think everything else just kind of took care of itself. I can't recall any other major roadblocks or major hurdles at the moment. Good question, though.
Great stuff. Great added in.
I've got a question for you regarding adopting the SignalR service versus hosting it yourself. It's kind of a different use case that I have. I actually have a Blazor server app, not a huge user base, but in order for us to scale it, we'd have to move to the service. Do you have any advice on figuring out how much it would cost for instance, right now, like I said, it's slightly different. Well, it is a different scenario. We're using SignalR, but it's through Blazor server. And in order for us to scale it, we need to move to the SignalR service. But I'm wondering how, because right now it's all just the server hosting stuff. We don't have that external communication cost. So I'm wondering how could we even estimate what it would take if, say, users were 10x what they currently are, or 100x? I mean, how do we estimate that?
When you go to create the Azure SignalR service, there's a SKU tiering, and that will actually show you, I wish I had included it on here, the different pricing models. There's 3 different modes. There's free, classic, and serverless. I think classic is the one that we went with. And I think most people will advise against serverless. I don't remember exactly why. I just remember that like stuck in my head for some reason. The pricing is based on, which of those modes you use, as well as how many connections your SignalR instance supports and how many messages get published per day. One of the things that you can run into is, let's say you have like 5 and I don't think you would run into this with Blazor. I think it automatically sets itself up correctly. But maybe you have 5 different types of messages that need to go through SignalR. You could establish 5 different connections per browser tab and do 1 type of message per connection. I advise against that. What's better is to treat it like a singleton and have a single connection of SignalR per browser tab, and then put all the different various types of messages on there. Just like you have 1 pipe running from your house out to the city, and there's wastewater. My kids love to put random stuff down the toilet from your bathtub. I mean, it all goes through the same pipes. That's the mentality to think about it, because otherwise you're going to 5x the number of connections that are going to be billed against you, and it can get kind of expensive quickly. So as long as you have, I think we maybe have like a max of 100 connections, because we only have, I don't know, like 40, 50, 60 users at peak. And then total number of messages per day would probably be like 10,000. I mean, even if you have extremely high parity following the 12-factor app model, you're looking at maybe an increase of like $200 a month if you have 4 environments with similar setups. And it can go up to a lot more. I mean, you can have, I think the max is 100,000 simultaneous connections, and then I think 10 million or 100 million messages a day. But like once you're getting into that mode, I mean, that's a lot of users. You probably have your hands full. It's like the Duggars, like they have 19 kids. Like their scale of problems are substantially different than my scale of problems with just 2 kids. They have many more logistical nightmares than that. So I wouldn't worry about that honestly too much. And I think there is a free tier that you can get away with if you just want to play with it. But we actually scan the QR code and drop me a note. We actually have another client that's using Blazor with SignalR, but I think it's actually on AWS instead. But I could kind of give you, like a pricing model for what they're using as a sort of apples to apples comparison.
Very cool. Thanks.
So yeah, their use case is different. They do Bible learning for Amazon tribes. So yeah, kind of great. We work on like everything. Like I'm not kidding. Like we even had like a social media network for preteen girls to help with their self-esteem. And then I get to do stuff with like a clinical call center. I mean, it totally runs the gambit of things I get to work on. So, hashtag dream job. So what other questions y'all got?
Any final questions for Zach out there? Well, I guess maybe we call it here, Zach. Will you be making your slide deck available?
Yeah. I'll send it out to the email that I got invited to this group. So yeah, I'll do that shortly after this.
Appreciate it. Okay, well, thank you everybody, and thank you Zach for the great presentation. It was really informative.
Yeah, thank you very much for having me.
Good night, everybody.
Thanks.
Good night.